So guys, let's start. Guys, so let's start. We are in the fourth of the fifth lecture, and today maybe I sent some fear for you, and I tell that this lecture will be more difficult, but in reality, I think the right word is more low. Today and the tomorrow we will go to lower details of how tech work, and some of this topic will be more difficult than the first ones, but most of them are just a low level of the system. So complexity will be rise not so rapid as I tell you. Today, our main topic is core technology, core typography, how TeX sees a document, and in what units TeX divides the document, and how you can make something like this, and why may you want to make something like this. Let's technical agreement we all use this, so let's go further. And first, let's tell about why we are learning all of this stuff. The main point of not what you see is what you get editors, as I tried to mention in the first lecture and yesterday, is the idea of separation. So that you can separate of what do we want to do from how do we want to do. For example, in previous lecture, we mentioned this tree, and besides all this header, all you want to do is to say that a tree has a node, and then TeX draw it by yourself. You don't need to think how you want to draw it. You don't need just to say that you want to draw a tree. And this is a very big separation, a very big difference between what we used to do in Word or PowerPoint or so, and something like this. Okay, but anyway, someone creates these rules. You can follow the rules, you can use the document that are following the rules. It is pretty simple, but who creates the rules? Obviously, they not come from nowhere. There is people who make it. And so the answer is the rules are created by the people who need to create them. And in this lecture, you will be the kings, you will be the men and women who create the rules and who can make ask tech to create whatever it want, whatever you want. There will be some things that are, well, they are ugly, because tech is a rather old language, so most of its concepts are outdated for today, and they may look ugly. They may look not as beautiful as in common, in modern programming language like Python, Kotlin, Swift, and so on. But still, we can use this ugly backend, ugly things that are hide from the user, and provide a very clear and very consistent front-end, a very consistent UX for the end users, even if the end users are us. TeX have lots of things that you can do. For example, at the last lecture, you notice this command, picture fraction. It was in the exercise. And in picture fraction, you have a font, for example, tiny or normal size or so on. A question, why does, in the hell, TeX not make this font to run in command, but not just apply it in the place where it is. Why you don't have something like this? And why I can make some comment like this and it will not produce the picture in place, it will be produced picture somewhere in the north upper of the page. It all is because how TeX work, and we will see how it works today and the next day tomorrow. For examples, I want to tell you some examples I create by myself for this lecture, for this cycle. For example, magic page you already know. You already see me with this magical head, and the UX is simple. I just write this comment, nothing less, nothing more, just this comment. You see the pattern of the lectures where we have some code at the left and some picture at the right. And always, obviously, this pattern was so open for me, so I create a comment for this. It's just like something like this. For those of you who saw the lectures, the versions of lectures for home usage, who opened one of re-lectures we sent for home usage with some footnotes? Who opened it, please? Raise your hand. Okay, a few of you. But there are some. You may notice footnotes with something like this. So I cut all this stuff to make it just an icon. And it's made by a simple comment like this. And a progress bar at the uppercase, I must do literally nothing except to load package, and everything else will be magically. But God help how dirty things I must do to make this. I'll show you. Yeah, I'll show you with my head because let's see. Okay, magic head. I already saved this code for you. It's have quite a few lines, so it's pretty simple, but still it helped me. Code and image pattern have more lines, and there are some things that you don't know yet. For example, new box and new length. It's what we'll learn today. Overall view have a very consistent dense pattern, but you can't understand it until the last lecture. And the progress bar, oh, it starts there, and it goes there. So all of these lines are just to create a nice UX for me. And today and tomorrow we will learn how to do this stuff, how to make the UX, the front end, simple and reusable by yourself. Previous lecture, we don't notice the difference between TeX and LaTeX. We tell about the TeX and about the LaTeX as completely synonyms. We tell, someone can tell that I want to make something LaTeX, someone tells that I want to make something in TeX, but they are not synonyms. And for today's lecture, because we are going lower, and to the second lecture, it is important to know that there are differences. I remind you from the first slide, from the first lecture, that the LaTeX is just macro extensions for TeX. So LaTeX provides a simpler UX, simpler frontend, as you will learn how to do, but it's at nothing less, nothing more. And TeX is a typesetting system. So the low program, the low commands will be written on TeX, and the more user-friendly commands will be written on LaTeX. And sometimes in our lecture, there will be a notice in the upper screen, in the upper part, is it TeX way or LaTeX way? They're different. And let's see how TeX sees a document, what it is for TeX. At first, we need to understand that there are several modes. Peter, I will ask you to send this example. So this is a short example. Please open the PDF from Telegram. Just copy all the stuff somewhere inside the document and see the difference. See that if, however, the lines are similar, first line is very similar to second line, this line is very similar to this line, and this line is very similar to this line. You see that they're similar, but the typesetting, the output will be different. Please come and see it. I'll give you a minute and then we'll continue. Okay, let's check how it is. I'll recompile it too for you. So this is just a moment. I will find where it is. And it's not. It's the section 1, and it is. Where this box? No. Okay. I can't recompile it right now. Okay, I can do it from Rhino Laravel leaf. Go to somewhere. And let's add this code to show the difference. Something wrong. Oh, okay, yeah. You need to make it Beamer. Make it Beamer and make it frame title. Okay. And what was the spaces between? There was spaces. There was spaces and there was spaces. Let's recompile it. No, I forget some spaces, I think. Yeah, I forget the space. Yeah. Yes, this is the stuff I want you to see. The spaces are important now. So if you lose the spaces after copy it and paste, add the spaces so because they're important. At first, the double dollars and $1. You see, the sigma have upper limit, these limits are to the left or to the right. Is it is to the right. Second, hello world, we have some spaces there and no spaces there. And third, most interesting and most contradictory is between this stuff and this stuff. So we have centering command, but there is no centering there, but there is some centering there. Who can guess why the last example works as it works? Who can guess why the first centering don't make the common centering and the last don't? Okay. But it is on the presentation that Peter sent you, so. So yeah, it's a presentation that Peter sent you. So you see this test is this, no centering, and this is this, there is some centering. Who can guess? It's not trivial, you need to try to analyze, but still you may guess and see why it is so. Okay, what's the difference? Okay, what do you see? What's the difference between one example and the second example? First and second. Please add the spaces. The spaces are important. Use the same amount of spaces as there, and maybe you need to put it to the beamer. Maybe you may put it to the beamer because I don't know if the centering is existing article. So put it to the beamer. Okay, well, no guesses, then I'll tell you the different, okay, the explicit difference are seen. There is no space between test and the n group there, and there is two spaces there. If I change this stuff to something like this, who remember what this command does? This command par. What does it do? Yeah, it's at paragraph, so the result is the same. And the answer is that TeX create paragraph as a whole. So centering will affect only when the paragraph ends. And in the first example, the paragraph ends before centering can do something, and the another part, in the second part, centering the paragraph ends because we have this par command, and or because we have these two spaces. Centering can took whatever it wants. Centering can center this thing, and only after it we can go further. So the answer is when this paragraph rendered. This paragraph rendered as a whole, this paragraph rendered as first it rendered this stuff, and second it rendered this stuff. Yeah, if we copy direct representation, there is some of these spaces are gone, so you need to add the spaces. Add the same amount of spaces and this and there. So this is where the spaces are important. And TeX have three, well, I guess 6, but 3 major and 2 not so major modes. You may see them on your work on your regular basis, but you maybe just don't know that there are 3 of them. The first division is very simple math mode. When you write the math, do you see that the math mode is completely different from the text mode? Do you see that there is another font, there is no spaces, there are some different rules, so the math mode is completely different. But also, TeX have one more division about horizontal mode and vertical mode, vertical and horizontal. As it names, The horizontal mode put the blocks together in horizontally, and vertical mode put the blocks vertically. So the easiest stuff when you need to put something horizontally, it's a letter. Could you guess what is the easiest, what's the most common stuff when you need to put something up to another in a regular document? What do you need to, where you use the vertical mode? What? Tables, yeah, but it's a contradiction, maybe a bit not common. Example, when you write the text, how do you divide the text? Logically, what the text division is? Guys, when you write the text, you divide it somehow. It's not a single text from the start to the end. You have a division. What is this division? What is its name? Yeah. And paragraphs are stuck one to another. And this is when you end the paragraph, TeX goes to vertical mode, and then he switches to horizontal mode again. And this is why, in this example, adding this paragraph, adding these spaces at paragraph, it makes some magic, because TeX goes from horizontal mode to vertical mode, and it changes the behavior. Okay, about internal vertical and restricted horizontal mode, I don't want to tell you. About display mode and math mode, you see this difference between $1 and $2. They different. They have lower difference, but still they have some. Okay, there is some difference between modes that I'll already tell you, and there are some different with styles that you can see, but we will not discuss in details. The second stuff is about boxes and glue. Everything you see is boxes or glue in LaTeX. If you see a symbol, it's a box. If you see a word, it's a box. If you see some space between two words, it's not space, it's a glue. If you see the sentence, some paragraph, it's a box. If you see another paragraph, it's a box, and they are connected with not just a space, it's a glue. And then page is a box, and so on, therefore. Everything you see is a box or glue. Images are glue, tables are glue, sorry, images are boxes, tables are boxes, and so on and so forth. Box have 3 params. It's you will expect 2 params because it's height and weight, but it have 3 params. It has height, it has depth, and it has width. So it's pretty common for typesetting that some letters are below the baseline. Yeah, box has baseline. It's pretty common that box has some elements below baseline, and so because we have depth, the height is, you see, is the height, and the width is it's width. So this is the box, meet it, and it is all what you need to understand how blocks or LaTeX do. Well, let's see another box. This is a box, G is a box. And you can see there 2 contradiction, maybe not so intuitive parts. At first, G, you see the reference points is not at this line, it's slightly below. Slightly above, yeah, slightly below. And another thing that you may be that may attract your attention is the letter F. F. I don't know how it's pronounced in English. Why it is interesting for may interesting for you? Who see what is interesting for F letter? Yeah, it has no depth, but see what's the width of this letter. yeah, who said out the box? Who is, yeah, you're great. And so the box is not, does not need too much the letter. The box is separate idea, the typesetting is separate idea. And often we will see it in the examples. You can make the box a size less than letter size, and LaTeX will see it as a smaller box, but will typeset all the stuff. Yeah, and if we have, and all this together is still a box, yeah. Well, then about paragraphs and pages creation. I announced yesterday that this is probably the most interesting aspect in the whole TeX system. How TeX create paragraph and pages. This is slide for perfectionist. If you compare Microsoft Word, Adobe, and PDF LaTeX, you see that the number of hibernation in LaTeX is much more smaller. Slide for perfectionist. And this is paragraph creation overview. So what interesting what we see in the example. Paragraph are considered as one, so the LaTeX can do something inside paragraph, but he can't do it something outside. And so if you see over full or under full warnings, whoever saw these two types of warnings, over full or under full? Whoever noticed this? Yeah, one person. Okay, nobody noticed, but still you may see these warnings. Moreover, overleaf, for example, make this in the triangle, and you can see that there are some notices. And what this means that TeX tries to create a perfect paragraph, but it fails because of the settings, and it says you that it fails. Well, I tell that it is the most beautiful idea in TeX, but we will not describe in the details because you know it's too deep for us. So there are a lot of stuff. Just let's see how many slides you need to describe this algorithm. There are a lot of stuff. You can manipulate the hibernates. You can manipulate the breaks. You can manipulate. You can tune the algorithm by how glue can how it's called elongate or scratch. You can do a lot of things. You can do really a lot of things, but it's pretty rare when you need it. Pretty rare even for our lectures, so we won't stop at them, even if it's the best part of the LaTeX. Also, you can do something interesting. You can type different paragraph size. You can do something like this, or even you can do something like this. If you want, you can make this crazy stuff. If, for example, you're an artist and you want to create, I don't know how it's called стихотворение in English, but how? Thanks. So you can do something like this crazy stuff. About paragraph, it was a really hard algorithm. About page, it's much simpler, just because in the time when TeX arrived, it has no enough memory to have global optimizations. So all you want, you can make some penalties. You can add new page and page break and so on. So page creation is much more simpler. And the next task, check, maybe it's in the TeX file I create, the first TeX file x03, check is it that. You see this box, and let's try for you to play a little bit and make it too. это второй, да? Окей. I asked Peter to send the PDF and the box play style file. Box play style file. So download this style file. It may be the first style files that are not installed globally by installed locally, but still you can use it as every package just by add a use package. Use package box play. And then use the command boxing dim around some object like this, like boxing dim double dollars or test of letter G. Use something like this in these lines and play and see, recompile, see the difference. It's just for you to play with it and to see how boxes make visible. So make these boxes visible. They're always in TeX, but they're invisible for you. Now it can be visible. So go on and try it. We'll wait for another 1 or 2 minutes. What I want to tell you, if you want to create the second task, please try firstly make this command leave vmod and then use boxing dim command. First leave vmod and then boxing dim command. Try this and see the difference. The leave vmod, as it may see, it's leaving the vertical mode and it's try to horizontal mode. So try this and see that there are not only height and depth, that there are width too. So make leave vmod before command, leave vmod before command and see the difference. Who need more time? Okay. Okay. Who has any questions? Okay. Okay, I'll tell about leave a mode for everyone and make this live coding too. Okay, so you have this box play. I'll say it in Papyria because I have this Papyria already. Right. Okay. The most interesting there is the mod, how it called, how it is a boxing dim command. Boxing dim. I hope it will compile because Papyria a bit slower. Yeah. So first, the most interesting thing in all this task is this integral, because you see the reference point is where the p goes, but the integrals go below this. And what is done with v mode? What is v mode? V stays for vertical. We talked right about 10 minutes ago about horizontal and vertical mode, and leave v mode leaves this vertical mode explicitly. If I tell something like this, if I write, for example, a letter L, that this will be done implicitly. TeX will leave vertical mode when it sees symbol. But if it sees just a space, it don't leave this vertical mode. So you may write a symbol, or you can make it explicitly by telling leaving v mode. Okay. And the next one, yeah, we have level 2, but I want everyone for you to compile. Add these comments somewhere, add this comment somewhere, and see what's happened to the boxes. So, for example, we have this integral. we have such integral. What will make if I have, what will happen if I use hash space -1 centimeter there? What will happen with this box? Try to do it. Try to add hash space, try to add var space, and see what will be the difference. What will happen? So what will be with these boxes? Try positive space, try negative space, see what will happen, and what will happen with this box. And you can type anything after this box, just type your letters, and see that it's not only the space, it's the typesetting ideas. So try it and see the difference. Okay, who needs more time? Okay, a bunch of you. Then I'll do it with you to see it. So if I have, for example, if I have no space, no hash space, and try something like this, I will have just these letters will be typed after the stuff. Well, Papyri is very slow, but still, what we have this stuff. If we have a space, if we have positive hash space, the box will be wider, and we see that the letters are indeed go wider. If we see negative hash space, if we have negative hash space, we will have something like this. So both integral is still in place, so we can see it. And the P letter is somewhere there. This is from D. But for TeX, the box is really narrow now, and TeX just types the next letters after it. And this is an important idea when you want to make something typed but invisible for TeX. Okay, let's go further. So we are going to TeX primitive. So this was a long introduction, and now we are going to understand TeX primitive, and I want to ask Peter for help, physical help. Okay, guys, girls, please. TeX has a lot of primitives, and because there are too many, I will not only put them in the slide, I will show you there just for you to stay focused. They have counter, commas, counters, slangs, spaces, glues, boxes, toks, and inserts. 8 primitives, 8 type of primitives. So these letters will be there just for you to stay focused, and we'll go to look at some of them. First, commands. We will focus on commands the next lecture. So for now, it's just the first look at them for you to just not to be afraid of them later. The simple command creation is like this: new command, the name of the command, and what will this command done when it appears. So the command sk will transform to Skolkovo Institute of Science and Technology, as you see there. Command sk appears there. And this appears there. So you can use it just as a shortcut. Command may have arguments, and you write it as 1 for one argument, 2 for two argument, and this command point it, just make it f box. So point it great, make it f boxes. And 2 arguments write in this way. So mention that it is not with a comma, it is not with spaces, it is not with some other stuff, it's just braces. So the first argument is first brace, the second argument is the first brace. Does this example clear for you, or do you have any question about this example? Okay, no questions. So the commands are very wide use, and if you write something by yourself, it's pretty common for you to create a new command just for stuff that is commonly used in your document. It's pretty common situation. And you see that to create new command is really simple. So yeah, you're a developer now, you know how to see this command, how to create command, and now you're at upper level. Okay, let's go to counters. Counters are, okay, we're done with this command. I will go there and create and mark that what we've done. We're done to comments for now, and we will, oh, it's bad marker. We will do something with this command at the last lecture. But for now, we see that these comments, we have these comments. Okay, counters. Counters are just integers that are used everywhere in LaTeX. Do you remember the lecture 2 when I told that there are implicit counters for count sections, for count equations, for count so on and so forth? Now we will meet them explicitly. In LaTeX way, so this is LaTeX counters. To create counter, you need new counter. To print it, you can print it as Arabic or something like this. You can add something to counters and print it again. So if you set a counter ABCD to 2017, it will be 2017. If you add to counter minus 27, it becomes this one. So pretty simple and pretty easy idea. You can print counter in various how it's called? In various ways. Okay, in various ways. So Arabic, Roman, upper Roman, lower Roman, and even something like this, where this notation is commonly used for footnotes in academia. There are some predefined counters. So part, chapter, section, and so on and so forth, this all have a counter. And there are some counters for tech, this year, month, day, time, and so on, and there are some counters more. And counter has domination. You see about domination again in the second lecture. And let's dive deeper, a bit deeper. So sometimes we have counters like this, but want counters like this. I'll ask Peter to send the PDF and the TeX file. I think this TeX file is created for this stuff, the third XML3. So Peter will send you not just PDF, but also a TeX file. You can just upload this TeX file in Overleaf, and I ask you to compile this code to see the output as you see there. Just compile the code that sent it by Peter, upload the file. Just upload this file from Telegram and compile this code. Upload the file. Do you need help? Yeah. Sorry again. Yeah. 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 We can. Okay, this is a good I will answer for everyone. Okay. Who already done this stuff and who compiled it? Please raise your hand. Who compiled the stuff? Who compiled the stuff? Okay. Who need help? Who are stuck somewhere and don't understand how to compile it? Okay, nobody. There was an interesting question about star command. Maybe you remember about something about this. If we use section, and if you use section with star, they will act differently. Do you remember the stuff that if you use star, they will act differently, and what the difference is? What the difference is? Who remember? Yeah, the first section will produce name, will produce this counter, the second will not produce this counter. So the question is, can we reproduce it by ourselves? And the answer is yes, we can. But for make this, we need to really compile to create two different commands. So the first command will be name section, and the second command will be name not section. I don't remember exactly, but it's just a separate command exactly a really new command. So you can create new command and add it absolutely attributed behavior. You can make the section to produce section and section with star to produce, for example, a dinosaur. You can do it. It just commonly used that this the star variant don't produce the counter. So I don't remember how to make the star command because it's not star, it's just something else, but you can easily Google it how to create new command with star in LaTeX and it show you. Okay, I ask you questions. Okay, I suppose so. Okay, you compile this, and now you will need to recompile your code and adding domination. I will show you, this stuff. Please go from line to line and change in your code the code from the left to code from the right. So you have somewhere in your code next counter, new counter. Do you have it in your code? Can you find it in your code? Please change it and make it new counter task with section in square brackets. Do it, recompile, then find that you have add to counter 1. You're adding something to counter, find it in your code, and change it to ref step counter task. And then change this stuff to this stuff and add renew counter to redefine, to make this stuff. So go change and add what you need to add. If you have any questions, you can ask. Okay, who struggle any problems with this task? You just find the new task in your previous stuff and change it to new counter, change this stuff to this stuff to this stuff, and add the last line, add this line. Okay, who done this task? Who proceed all 4 steps? Who proceed all 4 steps? 1, 2, okay. So you need 3. You need more time. Who have problems? Please raise hand and. And just a moment. After you have 4 steps, but not each step change something. All 4 steps does, and you can understand where in each of these 4 steps something is changed. But after all of this, the output will change. At the last line, run new command at this line exactly before begin document. At this exactly before begin document, and this will work. Okay, let's done it together. Let's done it together. Maybe I have failure, so let's done it. Maybe I don't add a thing there. So exercises. Oh, yeah. It's my fault. Sorry. You need to have a document class. Obviously, you need to have document class. Without it, it will not work. Okay, let's done it step by step. Firstly, what we need to do is to change new counter to new counter task section. Let's find where the new counter is. There it is. Let's change it and recompile. See, will anything changes? It seems that nothing changes. Oh no, something is already changed. You see the difference? If you make it there, this task is number 4. If you add it there, this task is number 1. So this is the first step. Second step, we'll change the add to counter 1. We change it by ref step counter. And now nothing changes, but this step is essential for next one. Then we change this task to create Arabic, where it is text brief. We change this stuff to this stuff. Sorry, we change this stuff to this stuff. Yeah, what's happening? Close before. Okay. Okay, we don't do anything with this, and we add new counter. The task. We add something like this. Maybe something wrong. Sorry if it is, but we will see. Maybe something wrong. The task, recompile, and let's change it. Oh, sorry guys. Yes, something is wrong. I'll try to make it there. Somewhere we have runaway argument. Ref step counter this one. Text BF, sorry. Boom. Okay, let's just see what it must be. Let's see what it must be. Yeah, sorry, this was broken. This was broken because somewhere I lose the braces, but I don't have time to understand why it is, but still this code works. I'll fix the problems later. Okay, we have something like this, and now we have what we want is this nicely done counters. Also, you can count something existing, but it's much harder. And and we can count something in TeX way. It has slightly different syntaxes. This syntax, this moment I will write. So, okay. You see the difference in TeX is that you have this equal and nothing more. So new count, you can use something like this. You can advance a counter by number. You can multiply it. You can divide it. You can manipulate it whatever you want. This is the TeX syntax. So new count test, and you can make it first 42. Then you can multiply it, advance 2, multiply by whatever you want, and see this year. And now we will have a break because this stuff, I think, was a little too tight for you. So we'll have a 10 minutes break to full your energy, and then we will continue in the rest stuff. But all the rest stuff is very similar. So the lengths are like counters, the spaces are like counters, the glues are like counters. So all the stuff will be the same pattern. Now we have a break, and don't forget to go to Peter and mark your attendance. Don't forget to go to Peter and mark for attendance. Okay. There are no several people left, so we hope they go there, but we'll slowly continue. Okay, we'll slowly continue. Maybe the counters was the simplest part, but it may be contradictionary. Why do you need it if you don't want to create your whole own system? So I'll start because of its simplicity, because it's just, counters are just integers, but maybe there are better starts. Well, let's go to length. Length is definitely something you need in LaTeX, because everything you pose this length. So let's talk about length as more common used stuff. First, length, we have absolute length in points, millimeters, centimeters, or inches. You can do everything like this, everything with this length. And you have not only absolute length, okay, yeah, you have some other length that you don't want. I don't want to use d-dot, anytime, but still we have some. And we have relative lengths. There are two relative lengths in LaTeX. It's YAM and YAX, and you may notice them sometimes. And if you do you remember the command #space, the command that adds space to your box? Yeah, that you have a few months before. And usually you don't use #space with centimeters or millimeters. Usually you want to add a little space, like a space as size as a letter, or a vertical space as size at, for example, 10 letters. For you need relative spaces. So YAM is for width of m, ax is for height of x. And if you make it huge, you will use something like this. Let's live code to create, to point why it is important for you, even if you don't want to produce your own packages, why it is important for you in everyday life. Because, well, let's create its new document. Let's create new page. Okay, let's see that if you want to type something. Okay, let's see that if you want someone to type a surname and name. But you want to have spaces, so you want a person to fill these gaps. How you can do it? You say that a typical surname, for example, it's 10 letters. So let's make space 10 x, so it will be about 10 size of x. And the name has, for example, 5 letters. It's really short name, but let's see that it will have 5 letters. And you have a space. Now you have a space to add a surname and a name, so you can just print it and people will fill it. And let's see that let's say that you want to add sign, but people will sign handwrite it, so sign is sign need a few more vertical space just to handwrite it, not to be stuck on this little space. So you add vertical space. For example, you add vertical space 3 em, and sorry, you need a space there because you go to vertical mode. And now a person have a space to write the surname, space to write the name, and enough space to sign as they want to sign. So this is a very common used example. H space and V space are really common used. Exactly is in EM and EX variants. There are some pre-built links. Text width, I think all of you use text width. Do you remember the text width is the length of the text? So it's just another length. And there are some other lengths, skip, indent, text height, light, and so on and so forth. And there are some another lengths from LaTeX and TeX. We will not tell about them more, but there are a lot of them. So everything in page have its own length. And now let's play a little bit. Peter, I will ask you to create a document where there will be a par indent. All you need is par indent this and indent this there. Put it to your document and then change it from 0 pt to any space you want and see the difference. We'll have a minute or so for you to do it. So just add this line to the document and change from 0 pt to, for example, 5 centimeters or for 10 em or for 10 pixels, and so on and so forth. Just change and see the difference. Changes this will change the par indent. Just see the difference, see that when you recompile it, you recompile it with different length. Something like this is really common use. Something like this, you may want to use no par indent. When you use your document, you may use attribute parent, and so it's commonly used even if you just type something for yourself. Okay, who done this task? Who adds this? Okay. For the rest of you, you can do it right now because the next page is about the same stuff. So this is just a printed of what you will have. Try it for yourself still. So if you have parent 1 pt, it will be there. If you have parent 15 pt, where it is, the regular one is 15 pt. If you have parent 4em, it will change for 40 pt. So just use parent in attribute space, in root attribute parent. Yeah, and in this slide you can see that there is some default. In the first line we don't mention any parent, but there is one. It's this number of parent, and also you can mention the package println. Package println simply print the length for you if you want to make it visible. We can change it and make it less. So we have 40 pt, and you can make it just 1.5 of this, and it will be 20 pt. But you can't use simple notation like this, plus, minus, and so on. You need to add dim_exprect. Yeah. Okay. So this is a whole example. There is a default parent at the first line. It's this one default parent. You can change it for attribute length there and there. You can have a half of this parent. You can't just use 2em plus 1 centimeter. It will produce something like this. It's not what you want. But you can use dim_expression with the same line, and it will produce something. You can use dim_expression with this line and quarter but with 2, and it will produce something. So if you want to have some hard parent, hard length, you can use dim_expression. For a simple one, you can use just this syntax with 0.5 pi. In LaTeX, you can also add length as a variable. You can set length, you can add something to length, you can show length, you can make length units. And this is example with LaTeX. Okay, create length, set for something, add 2 centimeters, and then it will be more. And use unit. And in TeX, again, we can add length, set length, add something to length, and divide length, and use dim_expression for make hard calculations, and show length with that. This is an example. Okay, who need help with the parent task? Who don't understand how it works and need help? Nobody. Okay, let's go further. So the length is very commonly used stuff. Yeah, the length is very commonly used stuff. It's used everywhere when you just type, and we mark it, we check it, and we have a few stuff left, Boxes. As you remember, box is everything in LaTeX, everything in LaTeX between spaces is a box. So you have hash box. Well, common boxing is just to make it visible, but hash box make, well, a box. You can adjust this to some length, positive or negative. You can make, you can adjust it. You can spread to add something, and you can make it, well, up, more wider, more narrow, and so on and so forth. And as you may understand from the first play task, when you make the box narrow or wider, its typesetting don't change, but it's change where the next symbol will be. And it is very useful, for example, for this task. If you want to create not equal, but forget the sign, you can make just something like this. So you have, firstly, you create this slash, make the size of the slash negative, and ask to print equal next. So because the size of the slash is negative, equal will be printed at the same place as the previous sign. And we have this stuff. Also, you can have something with tabling, something like this. And yeah, and we have vertical box. Vertical box is VBox. It can be again narrow or shorter. It can again be spreaded or highlighted. So you can have VBox for change something with height, and VTop with change something with depth. You have more boxes in LaTeX. You can create entire LaTeX style, this stuff with lower and raise, and you can do practically the same for vertical mode. In LaTeX, we have mbox and mboxes. We have maybox with some optional parameters, which is width of this box. You can change this. You can change the centering. You can change the size, and so on and so forth. You have the paragraph box for adding some space. Yeah. And you can use something like this. You can center it. You can center it something like there, to the up, to the down, to the middle. Well, do you know who quarter is? Who quarter space, please space? It's from one of the game. Who is old enough to play the game where there was a character who says space? Nobody. It's Portal. It's the first second Portal, yeah? So the second Portal, it's a Marvel's game. Please play Portal sometimes, and there is a guy who plays, it's not a guy, but a device who tells space every time. So you can do something like this, and it will help you when you need to. You have, well, some magic, something like this. And you can add box as a variable, you can save it, you can know the length of the box, you can, for LaTeX style and for text style, you can again save it, you can set it, you can print content, you can know the dimension of this box. Something like this. And why do you not need it? You will need it right now. At the exercise, I'll ask Peter to send the PDF and xprepare file, the xprepare tech file. So today I don't switch off the footnotes. You may notice this footnote there. The footnotes, they appear somehow. And you may notice when we will have some, I don't know, is there any footnotes that has 2 lines length? Yeah, you may notice that where we have a 3 line length footnote, it still appears in the screen. It's still there. And you have to create something like this. So the level 1 task is to create something like this. It's not the same as my footnotes, but it's still the good first guess. And you can use this code as a start. This code is a start. Everything you need is work is this field. This field is for you. Don't try to add something there. And don't try to add something there. You can try add something there. You can add new box, something to create such stuff. So what it is, the one-on-one, it's current frame number, total life frame number beamer. You need to Google how to insert this frame number. This one is the next year. Please don't make it by numbers. Use counter. Use the counter year and add the one to current year. And the length, the width of this footnote must be 2 part 3 of total width of the text. So this is the first task, and the level 2 task is this one. You need to update template, and if this template have more than 30 pt, the footnote must become a little bit wider. To create the second task, you need to store the box as variable and manipulate with the params of the stored box as a variable. You need to understand the height of this box before you print it. And for the first task, you just need to understand how to use the counter and how to make the right box choice. Again, if you don't know where to start, if you struggle with this, if you have no idea, please raise your hand and we will help you. Me and TeX are there for you. Okay, let's give some tips for you. Some tips for you to make it easier for you. Firstly, forget about the second and the third ideas. Firstly, try to make the footnote just this width and locate it downstairs. So just make just this stuff. So if it will be multi-line, it must have not the full length of the page, but just 2.203. Try this. This is done by one of the boxes you saw. We have several boxes that can hide, that can fix the space. For example, horizontal box. For example, this stuff have some space. Some width. This stuff has some width. And this stuff had some width per box. And this stuff has some width per box. For example, it has some width. Again, it has some width. So try to use, or maybe erase box had some width. Try one of these boxes. Try to wrap your text. Try to wrap this stuff. This is where the text is produced. Try to wrap it with some box. As soon after I will go with another tip for you if you struggle, but please don't hesitate to ask questions. So, yeah, and one more thing for you to make it easier to understand. I'll take it for you. Just a moment. Okay, if you don't understand what this crazy thing is, it's just where the text printed. We have this text and printed there. If we have there something like this, it will be printed there. So if the first line is confused you can make it explicit. You can make this just some kind of text there. If it not confused you can use this comment as just to know that there are some text that will be printed. So for now it has the width of the full slide. For now it has the width of the full slide to see. Make it to make the width of just less than full slide. This is the first task. Change something this. You need to add a box for this stuff. You can try multiple boxes, just use one of the boxes that was in our lecture. One of the boxes is all you need to create the level 1 task, this subtask of level 1 task. what we need to do is to make a footnote this width. Is there any box that can help us? Well, we have this box there. Per box have a parameter of width, and everything else is some text, and then it will shorten the text. So everything we need, as I tell, is one box. It's per box with the first parameter as some width. Let's make it, for example, for now 5 centimeters, just to make it sure that it works. We add this as per box, and now it has some width. Who done this stuff? Who finished this part? Please raise your hand. Who finished this part? Most of you, not most of you, but a bunch of you. Okay, it's good. So let's go next. We need not 5 centimeters, but some other width. So we have 2 past 3, and text width. But you see that this will not work. So something like this will not work. It produces some ugly stuff. But do we have knowledge how to manipulate with length? Let's go to the length slides. When we go to the length slide, you see that we have the length manipulation with dim-expr. We show it there, dim-expr. Dim-expr is what all you need. So let's add dim-expr for this text and see what happened. Nothing will happen. Okay, just a moment, I will see why. Yeah, maybe something like this. Maybe something like this. I need something like this. Yeah, I need another syntax, so this will work. So it's indeed the needed length, and all we need is to add what's the task. The task was to add the current frame number and the total frame number. Let's try to do it. So we don't know how to insert it. Let's Google Beamer total frame number. Beamer total frame number in Roman. So we have insert frame number. For example, I think it will insert the needed frame number. And insert total frame number. Yes, that's all we want. Say frame number and set total frame number. The first link is what we want. Let's make it there and see what happened. Well, we have a good idea, but still we have some problem. You will see this if we have a more longer text. You see that this one goes upper and upper. It's not stuck to the left, to the top, and there is to the top. But again, we have our par width. We see that par width has different kind, and if we use par width with B symbol, it will move. It will move it down. And it is the first half of the task. So everything else, we done this stuff. We done this stuff. Only with common par width. Par width, there it is. Only with common par width. So the last task is to create a year. Well, let's go to the here is a counter. Let's go to the counter sections. Counters there. And how to create a how to create a counter. That is the next year. So we need a new counter with comment new count. New count next year. What we need? First we need to set it somehow. Let's set it. Next year равняется current year. We know that this year is our counter year, and we need to advance it somehow. So let's just copy the manipulation. Advance by 1. Next year. We advance next year by 1. And printed the next year. And here it is. So this is all for first task. And now when I tell you the solution, is it sound difficult for you or you understand the solution? So who understands solution? Please raise your hand. Who understands the solution? Okay, most of you who don't understand the solution, do you have a question that you need to ask, that you want to ask? No, you don't have? Okay. Then the level 2 task, I will not make it live coding, but I will show you the solution and explain it. So if the text footnote is higher than this number, it must be wider. So I will show you just the solution, and you will see that it is not so hard. Well, it's hard, but not so hard. I gave you a tip. Then when to check the footnote height, you need to manipulate with boxes. And to manipulate with boxes, you need to create box. And we create box like it was in slide. Create box. Yeah. Then you need to make this box. You need to fill this box with some content, so LaTeX will see what is content length. We fill this box with par box. We say that save to the box my box this par box. So we send it, and now we need to create the length. You can see in the slides that the length created by new length, and we have set to height, and give us the height of the box. All of these are in the slides. So we have set of height, and this one is what you're supposed to Google, but the syntax is pretty clear. If box height is bigger than some parameter, you need to use par box with wider length. Else, just print it. And that's all. I'll show you the information, that you have this information on slides. Yeah. This is all you need. You create this box. This was the example. You fill this box with some box, with some existing box, some content, and you can set to width, send to height, and send to depth. Now is the principle of how you can do such crazy things is clear. So create a box, see the dimensions. If you need wider, just create another box, create another content. Is it clear? Let's go further. Let's go further, and this is all you need with the boxes. The boxes are content that are some concept that is not very common used in the regular life, but still I hope that you understand now. to create a box and how to manipulate the box, and why in the hell we need somehow to first save the box and then to print the box. It is to check some conditions. Next, we have glue. We have glue and kern, the two different stuff. And glue and kern provide some spaces. You see, there is no space between glue, and there is a lot of space. So glue and kern are for spaces. And please, Piotr, can you send just this line? Try to write this line in your document and compile it, see what will happen. So if you use some syntax like this, what will happen? Please try to compile. This line, you can get it from there, or you can just copy it from Telegram, try to compile it and see what happens. Мне кажется, ты не пытаешься понять, что произойдет. Ну, скоро закончим. Попробуйте хотя бы этот пример скомпилировать, может у вас получится что-нибудь выжить. This concept are a little bit not so common used for everyday life, but still we are closer and closer to programming. You know, if you have programming experience, you can see that this is the programming ideas. You have variables, you can add something to variables, you can put something to variables, you can modify variables, and so on and so forth. Who done this stuff? Who add this line and compile it? Okay, who see not what you expected to see? Who sees that something is crazy? Yeah. This is why. Okay, we'll. Who need more time to make it? Let's wait for a minute, and I'll say what the problem is. Why this line of text produce such unclear, unexpected result? Well, we will wait this minute. Meanwhile, you can guess if you already make this task. You can guess why it is so. You can guess why the result is so unclear and so contradictory. Okay, we'll wait for another. Yeah, you have a question or answer? Okay, so who done this task? Please raise your hand again. Who done this task? Who have the result? Okay, most of you. Let's go further. Please. Okay. By the way, guys, if you stuck in previous task, we have two TAs. Well, where is one? Okay, we have one TA, and he can just go for you and help you with tete-a-tete conversation. It's okay if you stuck, and it's okay if you want to understand. Just ask Peter, and he will help you. You can write him a telegram, I think. Okay. What is glue? Glue is not just space. When I tell that it is space, it was a lie. Glue is a tensive space between blocks. So it can be wider, it can be narrow, and everything is glue. Okay, just a moment. I want to give this man a sticker because he is brave enough to ask Peter. Be like this man, please ask Peter, even if it is for previous task. Okay, so glue is sensitive, it can be wide or narrow, and this syntaxis plus minus is the border of the glue. So it usually it has such kind of length, but it can be wider in this task and narrow in this length, and so LaTeX see this as a keyboard. So the syntaxis is this normal length plus minus. Now, please relax. Relax and add this relax command before plus. Between 0.5 em and plus. Add the relax command. Add the relax command there. Please add the relax command there and recompile. And relax a bit. In LaTeX we have not just a lot of braces, we have a relax. I really like it. So who recompile it and have a new result? Raise your hand. Raise your hand who recompile it and make result, so I will see that you are ready. Okay. Okay. Add relax command there, in this place, before plus. If you have any other questions before in previous task, still ask Peter and he will help. It's okay to start with previous task, but you can ask us. We are here for you. Okay, who done this task? Who add relax command and sees the new result? Most of you. Okay. Yeah, and you see that everything good now. Relax is the command that produce nothing, but it help you to say that the command is over and now it's just regular text. If you have some unexpected stuff when you produce command, use relax and it will help. Glue is not just explicit stuff, it added implicitly everywhere. So all these lines change because of the glue. So I just use I created with this stuff, with hbox spread from minus 40 pt to 40 pt. You see that I don't have explicit glue between this dot and hash, but still there are some glue. They tense. And you can still see that the tense between words, is lower than the tense between sentences. You see that the sentence has more space. Yeah, guys, the glue in between sentences is more than the tense between spaces, between words. And it's the typography of LaTeX. So it's how it works. It's try to make the sentence, the paragraph good to see. How to use glue in our work? You can use skip or space, skip or space. So when you use space earlier and space, it wasn't just a length, it was a glue. And Peter, I want to ask you to send this task. In this task, it for you for rest a little bit and not to think. You see there is glue1. Glue1 is there. And glue2 is there. Glue1 and glue2. Replace this glue1 and this glue2 with one of the following. 1, 2, 3, 4, 5. So try the different combinations. Replace glue1 and glue2 with one of this stuff and try the different combinations and try to understand what is this stuff, what will do, what will be created. Peter, you sent? Great. So go to Telegram chat, use this code and replace glue1 and glue2 with 10 EM, 1 fill, 2 fill, 1 fill and 1 fill. Try to do it. Who has this problem? Do you change this glue1 and glue2 to real numbers? So this is must be the problem. So please change this glue1 and glue2 to number and yeah, it will not be compiled if you left glue1 and glue2, but if you have 10 EM, for example, and 20 EM, it will compile. So yeah, now it's compiled. Sorry, it's just. So if it's not compiled, change the glue1 and glue2 to one of these numbers, to one of this stuff. Don't leave it with glue1 and glue2. Don't leave this stuff. Да, вот без фигурных скобочек, без этих. when I tell to modify it, I don't make like this, but remove these brackets too. So this syntax, you need to have some syntax like this, not with these brackets. You don't need these brackets. Remove them. So this is an example of correct syntax. Okay. Who compiled at least one result have? Who have at least one result? Who have at least one result? Most of you, but not all. Okay. Peter, can you go somewhere there and ask? And who can compile it once? Who have problems with compilation? Please raise your hand. Who has problems? Okay, we'll go for you. Who else has problems? Okay. Подойди к девочкам вот туда вот. Okay, who else has problems? Please, who can compile it? Okay, if you compile it once, then go and compile it with different parameters and see what will happen. Okay, who done the stuff? Who search for? Who add the different stuff? Who add the different variants and see what happens? Who done this task? Please raise your hand. Okay. So what do you think? What is this crazy one fill, and one fill? What do you think? What it is? What do you notice when you compile this task? What do you notice? Can you give me any examples of results you have? Yeah, and when the text position is changed, how this position change? Yeah, the ratio is about, okay, let's go and see. We have infinite glue. So this changes was because of infinite glue. And infinite glue is the power of L, and LLL are the power of this infinity. So you can use just infinite glue with fill. You can make it more powerful with fill and more powerful with fill. And if there is infinite glue, it's much stronger than any else glue. Anything else, if it has more powerful infinity, then it will be stronger than the previous. There are some abbreviatures to make this stuff simpler. And infinite glue, in fact, it is widely used in the situation when you need to center some stuff. If you have, for example, a picture, obviously you can use begin center and center or centering, or you can just add infinite glue in left and infinite glue in right, and it will be centered by itself because it will have two equal infinities. You have glue manipulations, but we don't usually use this glue manipulation. I never use it in my life, but still we can do it as well as for any other variables. For example, this one, and LaTeX and so on. Also we have spaces. And the spaces, these spaces, it's in the fourth lecture, but actually the idea you need in the first lecture. who use LaTeX and ever use this stuff. Qt and Qt. Whoever does this. One person. Okay, not so many. This stuff is really complex for typing equations like this. If you type equation and want to make, for example, x is y when x is more than 1, you need to this second part to have to be separate from the first, and it's done by quad and quad. Also, you have some some spaces like this, and this is done. These spaces are used, for example, to create dx in integral. If you use, for example, x on dx, you want to make the space between d and x narrow, then it will appear, and you can use something like this. So the spaces are useful in math. Also, we have phantoms. Phantoms is just something that have size of content, but don't draw this content. So, like this. Phantoms is maybe used if you want to have not to draw content, but know its space. Phantoms. And also we have Toks, and we will not talk about because they are too complicated. Toks is like string storage, and inserts for create some footnotes and so on, but I can't provide a working example, so we will not talk about inserts. For now, I will send you the result of previous result. So where it is, I will send you the previous result. X. So, okay. This is the last task for today. Will be the last for today. We have this result that I will send you by just downloading and uploading to you. I'll firstly compile and see that this is the previous result, and then let's try to add some glue. It's pretty simple. Just make this stuff in the center, add some space between this and this. This is done by infinite glue, and if you can see the infinite glue, find the infinite glue in slides, you can add it and make something like this. As a level 2 task is a bit more complicated, you need to do this stuff. It's a level 2, but first we done level 1 by adding a glue where you need to add a glue. And as always, don't hesitate to ask questions. Upload the file. I just sent to Telegram. Yeah, this is the last X0. Yeah, please. So upload the TeX file that was the result of previous task and try to implement something you see in the slide, and the whole task is on the presentation Peter sent for you. Make footnotes anywhere. So we will have about 10 minutes for this task, and then we will go to the end. So 10 minutes for you. Try to do it, ask questions if you need. Okay, who done level 1 task? Who done level 1 task? Who done level 1 task? Please raise your hand. Okay, who done level 2 task? Nobody, yeah. Does anyone need more time? Okay, so you need more time for level 2? Or for level 1? Okay, then I give several tips and give a few more minutes, but just a few because we are near to the end. So the glue there. We need infinite glue. And the infinite glue is, for example, what we need is to add, for example, hash fill or hash space. Add it to two examples, and you will to the left and to the right, and you will see what happens. To make something in level 2, the most contradictory part is how to compensate the asymmetry between things that happened before box and after. It may be done with Phantom, and I will tell you how to do it in a few minutes. Let's give 1 more minute for people who want to end the level 1. Then it will be a few live coding, and we will go to the end. 1 minute for you to try to finish. Okay, view live coding is simple, as I tell. So you have this par box. And all you need to do is to add hash fill there. For example, you may use hash fill, you may use, for example, hash space. And recompile. And you make it, and this is all you need. This is all you need there. By the way, well, very often you can, guys, maybe one of the last things that you want to hear. By the way, you often can see the syntax like this, with percent at the end. It is because if you not put this percent to the end, you will see an additional space. And you don't want to have additional space if you are a perfectionist. So this is no spaces, this is additional space. And level 2 is pretty easy yet. What you need is, by the task, you need to delete this line. You need to delete this line and delete this. And now it is somewhere to the end. What to do? One example is to make this stuff, make it phantom. Sorry, get phantom. Okay, by adding this command, we tell LaTeX that there is an invisible number of slides. So this is how it is done. It is centered there. But there is a crazy thing. If you have a one-liner, this will not work. So for this, why it's not work? Because the parbox has the fixed length. Parbox has a fixed length, and if we, for example, add a word there and recompile, see, it was started there, and it still started there. So if you add some words, it will go to the left, and this is why it's not centering. So what we can do is just add center. Just add center in there and see that it will fix the problem. That's all. All level 2 done. This. Let's go to the end. Our time is running out. So today we see about 8 primitives. Well, working with these primitives are primitively easy. You define it, you set it for some value, and you somehow adjust it. The main shift of your mind is that before you was thinking as a user, and now you need to think as a developer, as a programming. So the main problem is the complexity of algorithms that you need to create these algorithms. It's not the problem of the tech itself. In this class, some things are commonly used for user level 2. For example, phantoms and the maths. This stuff and length are commonly used for user level. Some of the elements of this lecture is also useful for the user level, but most of them will help you if you create your own template, or if you want to adjust a little bit another template. For example, you want to make it a little wider, a little higher, and so on. So these elements of this lecture can be used as a user, but most commonly used for the developer. We have only one more lecture, and please raise your hand who thinks that he is programmer, who can understand programming code easily, who can see that, in a one leg inputs programming. A few of you, okay, a few of you. So for you, the next lecture will be easier because we will go to deeper to programming of LaTeX. For others, it will be harder, and maybe the next lecture will be not so necessary for common life, but still it's finish the whole tech course. After this, you will understand everything about LaTeX, so try to understand at least simple parts, and we will not push you too hard to understand the hard ones. That's all. As always, please send the assignment to Canvas right now. Don't forget. Please send the PDF to the Canvas, and see you tomorrow. We'll hope that the last lecture will be interesting for you too.